Okay, so this question, not overly hard, just a bit wordy. Okay, so Terry is an avid skier. The equation that best models his favourite run is given by h equals this, where h is the height in kilometres above sea level, and x represents the cross-sectional width of the run in kilometres. The run terminates at a place that is 1 kilometre above sea level. So let's start drawing something. So that means that I'm going to have a line here that is 1 metre above sea level. I can represent that line as y equals 1. Now, Terry's going to be having his little fun slope going like this, and it terminates here at that point. So the cover of the snow on the mountain is 2 metres, and the run is 300 metres wide. Calculate the volume of the snow. So that means that this slope is going to have snow above it as well. Now, the whole way across, it's going to have been shifted up by 0.002 because 2 metres, actually, let's double check that. Metres to kilometres is times 1,000. So we want to divide by 1,000. Wait, those arrows should go the other way. Blip. Okay, anyway, so 2 divided by 1,000 gives me 2 divided by 1,000, 0.00123, like that. So did I get that right? I did. Excellent. Okay, so first thing we're going to do is find the point of intersection here so that I can do my integral between 0, which is here, and this point here that we'll just call a for now. And then in the functions, we're going to have, because we only want this area in between. We only want this part. So I'm going to do the blue function minus the pink with respect to x. Okay, and that's going to give me this cross-sectional area in between here. Now, with that final thing, volume is equal to the area of the front face multiplied by the depth. Now, it tells us that the run is 300 metres wide, meaning that the depth is going to be equal to 0.3 of a kilometre. Make sure everything's in kilometres, otherwise this is not going to work out for you. Okay, so first things first, let's work out our blue function. So the blue function is going to be 1.8 e to the power of negative x plus 0.43, and then we're going to add on the 0.002, so that'll give me that little 2 on the end, minus the pink, which was just our original equation, e to the power of negative x plus 0.43, bracket, and we're integrating between 0, and I need to find that point of intersection there. So that's my next step. So menu, nope, execute, exit. So you can see I've already put those functions in. Now I've put in the pink function as this one to find that little point of intersection that's going to be here, because that other one is going to be 0.02 above it. So execute. Now I'm going to, what am I going to do? I am going to G-solve the intersect point. So that is going to be 1.1499. Now I do have options here. If I get rid of this function, I can do it in the graphing section and work it out by just, standard. So 1.8 e to the power of negative x with my x plus 0.43, execute, draw, and now I'm going to G-solve. I'm going to integrate look, if I chuck this whole thing in the calculator, it's going to give me, I didn't write down the answer. It's going to give me an answer, and then to find the volume, I'm going to do that answer multiplied by 0.3. Yeah, look, it's not giving me what I want. Okay, I'll play with that later. Okay, so here we go. Option, calc, integral. When you do this subtraction, you're just left with 0.002. Close my bracket. Between 0 and 1.499. Execute. That gives me 2.98 or 998 e to the power of negative, or 10 to the power of negative 3 is what that means. So if I do that over here, 2.998, this is moving forward 3 places. 1, 2, 3. There we go. So it should be 0.002998 times 0.3 is our volume. So the volume is equal to 0.002998 times 0.3. Execute. And that gives you 8.994 e to the power times 10 to the power of negative 4, which I don't think is the answer. So let's have a quick look. Yep, I've just got a rounding error, which they don't have. So my rounding error is here. I've used the 9s when they've just rounded, or they've used something less exact. But, you know, whatever. Close. Much of a muchness. Don't forget your unit on the end. So that means that our volume is going to be equal to 0.0009, we'll call it, kilometres cubed. Now, it doesn't state what it wants the unit to be in, so it doesn't matter. I can leave my answer like that.